Hello, today's lesson is on transformations of functions, section 2.6, and we will be dividing this up into a couple of different sections today. So your assignments will look a little bit different. One day it will be online and the other one will be through WebAssign or a worksheet, sorry. So we're going to look at shifting relations vertically, horizontally, and algebraically and graphically. And then we're going to reflect relations both algebraically and graphically, and then perform non-rigid transformations both algebraically and graphically. Now, we don't know what those are. We're going to find out. Okay, and I encourage you to pause this anytime you're drawing on your notes or whatever, so you don't miss any information. The first graph is simply y equal x, which is an identity. So that is just a line with a slope of 1. An absolute value is y equal absolute value of x. That gives us that v. These are all called parent functions. The square root function is y equals square root of x. The quadratic, obviously, is y equal x squared. Again, pause these and draw those in there. Cubic are y equal x cubed, and there's a reciprocal equation, y equals 1 over x. Now, what we're going to do with these is we are going to transform them. There are rigid transformations and non-rigid. Rigid means we do not change the shape or the size. We just move it around. Non-rigid means we change it a little bit, and that requires some shrinking or condensing or pulling, making bigger, making smaller, etc. So horizontal and vertical shifts are as follows. If we're going to move it up or down, we add or subtract a constant. Horizontal shift, though, right or left, is what's inside the function itself. We're either going to subtract or add a constant. And when we do that, parentheses lie. So therefore, if we subtract a constant, we move it to the right. If we add a constant, we move it to the left. So that's how it differs from vertical shifts. If we reflect it in the coordinate axes, if we negate the entire function, we reflect it on the x-axis. If we negate just what's inside the function, we reflect it on the y-axis. And I might have to refer to this several times to keep it straight myself. Okay, so on number 2, for each function, state how the parent function has been shifted. All right, so on the first one, square root of x plus 2 means that graph has been going to be moved up 2. Letter B, well, it's inside the function, so it's going to be left 4. Because it's inside, it's opposite. Again, parabola, it's going to be moved up 3. Okay, a cubic, but it's inside the cube, so that means it's right 3, but this is still up 2. This obviously is down 3 and right 5 because it's within the function itself. Then we're going to do the opposite of what the sign tells us to do. Again, I'll let you freeze that and digest it as we move on to the next functions. Okay, now if you recall, the negative sign in front, when we negate the function itself, right here, it's a reflection on the x-axis. So this is going to reflect on the x-axis, left 10 and up 5. Here, all we're doing is negating the x. So this is going to be reflected on the y-axis, left 8, because it's within the function itself right here. The function is square root, the parent function, and then up 4. So now we're going to write an equation for f of x equals x squared using what they tell us here. Move 3 units right, 7 up, and reflect it around the x-axis. Okay, so x-axis, we negate the whole thing, right? So we're going to negate x, let's see, but were you supposed to move 3 units to the right? So negative of x minus 3 quantity squared. So that gets us our reflection and our movement right. If we're going to move it up 7, it's plus 7. There it is. There's the function. Okay, the next one is a radical function. So we're going to move it, okay, around the x-axis again. Okay, so it's going to be negative square root of x, let's see, 5 units left means plus 5. And then down 6 would be minus 6. But we only negate the function, not the minus 6. All right, now this is where we get the vertical stretch or shrinking or horizontal stretch or shrinking. And read carefully. The vertical, this is a non-rigid transformation. A vertical stretching or shrinking. When the y value of a function is multiplied by a positive constant, the result is a vertical stretch or shrink. So we're going to take a constant and multiply it by the function. It's going to be a vertical stretch if c is bigger than 1, and a vertical shrink if c is between 0 and 1. Now, what about negative? Well, remember, negative out in front means we're going to reflect it. We're going to reflect it on the x-axis. So the shrinking or the stretching of the function is just basically from 0 to infinity. That's it. Because the negative just flips it on the x-axis. Okay, now horizontal shrink or stretch is just the opposite. It's a horizontal shrink if the constant is on the function itself, or a horizontal stretch between 0 and 1, just like before. So you can see that it's a stretch vertically or a shrink horizontal shrink if c is greater than 1. So just a little bit different. All right, so for each function, state how the parent function has been shifted. Now, this is a lot of gobbledygook. So right away, we know it's reflect on x-axis, right? We also know it's up 2 and left 5. That stuff's easy. But now this 3. Well, that's the constant. It's on the outside. And remember, if we go back to our rules here, if it's outside, it's a vertical stretch then, since c is bigger than 1. So this is a vertical stretch of 3. All right, I encourage you to do the next one. Pause it and then come back to it. So the first thing, the 1/3, so it's still a vertical, but it's a vertical shrink of 1/3, or 3, basically, 3 times less. It's right, move to the right 3, and up 1. Those are kind of fun. Now, we are going to stop there for the first lesson, okay? The second lesson for 2-6, so this would be our next lesson, is determining the parent function, determining the equation from a graph using the parent function. And we're going to use this formula right here. So we're going to have to determine the parent function. We're going to have to determine whether there's a horizontal shift left or right, whether there's a vertical shift up or down, whether there's a vertical shrink or stretch by plugging in a point and solving for A, and then we're going to write the final equation. So we got some work to do here on these problems. Okay, so what is this graph? Well, it's going to be an absolute value, isn't it? So C, absolute value of x. So now we determine a point on the graph and substitute it in to find C. Okay, so if we're going to determine a point, it looks like 2, -1 is a point, and 2, -2, -1 is a point. All right, so that's something to think about. Okay, so there's no vertical shift, there's no horizontal shift. So it's a shrink, or it's a, right, or it's a stretch. So we're going to put -1 in there, and then our constant, and then our x. And in this case, x was 2 or -2. And we get C to be -1/2. And the negative obviously flips it on the x-axis. So our graph then is actually -1/2 absolute value of x. It's pretty slick. It's vertically, let's see, it's a half, and it's on the outside. So it's a vertical stretch of, or a vertical, shrink of 1/2. Okay, how about this guy? Well, we got to pick a point. We have C equal x squared. Again, looks like 2, 1 and -2, 1 are points. 4, 4 and -4, 4 are points. So we can pick any of those. I'm going to use -4, not that it matters, because we're going to get the same answer. Looks like 1/4. So our constant is 1/4. So our graph then is 1/4 x squared. Now we have this equation. Well, we know our parent is f of x equals x squared. And we're going to have to use, we have an A. We have, it looks like we're going to be shifted as well, plus h, so we have a horizontal shift, and then possibly up or down. So that would be our parabola. We have this is our stretch or shrink, whatever, and then this is the rest of our stuff is our movement. So we have A, let's see, it's been shifted over 1, 2, 3, 4, 5. So that's going to be -5, right? Because it's to the right. And then up 1. Now we need to pick a point that we can see clearly. I think that's 1. So 2, 4, 6, 8, 7. So 9, -7 is a point. So we need to find A. Ooh, let's see what this looks like. We need to find that constant. So subtract 1. -8 equals A, 4 squared. Looks like 16A. Yep, looks good. -1/2. So this function then is f of x equals -1/2 x plus, x minus 5 quantity squared plus 1. Pretty fun. Okay, absolute value. I'm going to use G, not that it matters. Parent function, looks like it's been moved though. So I have a C there, but you can make that anything. I typically use an A. It looks like it's definitely been stretched, or yes, and it looks like it's been moved left and right and up and down. So the horizontal shift is left 1, so it's +1, and then down 1. Now we got to find a point. Looks like 0, 4 is a point. So 4, ooh, that doesn't look very good, does it? 0 plus 1 minus 1. So that's going to be add 1, you get 5 equals, so there you go, A is 5. So our equation then is g of x equals 5 absolute value of x plus 1 minus 1. Oh boy, we got some doozies, don't we? Excuse me. Okay, so now we got to use, we got to graph these. Okay. So use the graph shown to sketch each of the following transformations. So here's our graph that we're going to use right here. And we're going to do this transformation. So this says up 1 and right 2, correct? So right 2 means negative 2. And then we're going to add 1. Negative 2, 3. So there's that point. Now this point. Negative 2 means right 2 and up 1. So I believe that put us there. 0, negative 2 would be over 2, up 1. That put us there. And is that 6, 2? Yep. So right 2 would be 8, up 1, so it'd be 8, 3. And I think we got the graph we were looking for. There's the shift. Letter B is simply everything moved down 3. So negative 4, 2 would be negative 4, negative 1. Negative 2, negative 5. 0, negative 5. And 6, negative 3. No, 6, negative 1, sorry. And there's my graph. Okay, same graph. Ooh, a little more thinking involved in this one. Okay, so we know we're going to move it over 4, right? To the right 4. But now, and then we have this 2, this negative 2. We're going to flip it. And we're going to have to vertically stretch it by a factor of 2. So if we vertically stretch that, let's see. We know that our point is 0, negative 2. Let's start with that one. And we're going to go right 4. 1, 2, 3, 4. And then we're going to vertically stretch it. I don't think we're moving that then, are we? Oh, we're going to flip it, sorry. So it's going to be up here. We have to flip it because of this negative sign. 6, 2, let's see. So it'd be right 4. Then we're going to flip it. So it'd be 10, 4. 10, 2, sorry. And then we're going to double it. And what part do we double? We double the y value, so 10, 4. 10, negative 4, sorry. Oh, we forgot to double that y value, didn't we? So that would be 8. I apologize. So that would be 8. So negative 2, we'd flip it, and we'd move it to the right 4. So it'd be here, 1, 2, 3, 4, here, and then we double the y value, which in this case would be, wait a minute. Yeah, I think that's right. It'd be 8. And then we would do the same thing with negative 4, 2. So we'd move it over to the right 4. So it'd be 0. And then we'd flip it. And so 0, 2, and then we'd flip it. We'd be down here. And then we double it to there. And there is our doubled. There's our stretching of our function. And that looks funny, does it not? Okay, now this last assignment is a worksheet over looking at a graph and moving it or determining the equation